Okay. The critical part is how to get Qx. Always the first moment of area is our problem. So Qx is equal, so Qx means what? First moment of area about the what? X-axis. So x-axis is over here, right? And the next one is equal to area y bar. Y bar, so y bar is this distance over here. So this is our y bar. A lot of times students get confused, okay? And then the area to consider is this area. Okay, the area to consider is that area. Okay, so like typical, I will call width multiplied by depth multiplied by y bar. So we know the width, right, is 75 times 10 to the power minus 3. Right, the depth is my TF. Right, TF is 11.8 times 10 to the power minus 3. Okay, then the y bar. Okay, the y bar. Hey, come on, Eugene, come on. The y bar is equal to what? Y bar is equal to the D divided by 2. The depth, I forgot what is the depth value. The depth is what? 0.205 divided by 2. 0.205 divided by 2 minus by 11.8 times 10 to the power minus 3 divided by 2. So this will be equal to 75 power minus 3 times by 11.8 power 75 power no 0.205 divided by 2 minus by 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 times by 75 power minus 3. So it's equal to 85.491 times 10 to the power minus 6 meter cube. Let me do it again. 0.205 divided by 2 minus 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 times by 75 power minus 3. 85.491. Okay. So that is our Qx. Okay. So now we can find the shear is equal to Vy is equal to 25 times 10 to the power 3. 85.491 times 10 to the power minus 6 divide by 40.8 and then divide by 11.8. It's a white flange analysis. Okay. So this is equal to 25 power 3, that's why 85.491 power minus 6 divided by 40.8 power minus 6 divided by 11.8 power minus 3 is equal to 4.439 times 10 to the power 6 Pascal. Okay, so again 25 power 3, that's 85.491 power minus 6 divided by 40.8 power minus 6 divided by 11.8 power minus 3. 4.439. Okay, now there is a direction down here. It's neither a positive or negative, but you have to draw what direction. The direction is relative to your shear flow. So if we were to construct our shear flow, I make it smaller. If we were to construct our shear flow, it will go like this up to element A, yes or no? It will do this, yes? Yes or no? Right. So this is our Q, our shear flow. So this is going towards the right. Okay. I'll tell you later on why it's important. Now just do this first, okay?
But it could be in any direction, right? You said.
Huh?
Like from
What?
the previous lectures, you said that the shear flow could be in
Yeah, that is
direction.
the shear flow. Opera is the shear flow.
Right, but you said it could be in any direction. So basically, the what's it called?
Wait. Okay, you're literally taking my words word by word. Why it is that direction? Because this is your Vy. If Vy is from the top, the direction will change. Yes, Okpara?
Okay. Okay. No, because
Okay.
from the previous lecture you said that after drawing by
You're taking my word literally. Okay, you have to see the analysis. Okay.
okay.
Okay. Okpara, you are a good man. You know. You know why you are a good man, Okpara?
Why?
Only good men listen. Okay, I don't listen. That's why I have to get divorced once. Okay, you are a good man. Seriously, men don't listen. Okay, right. I'm not saying Opera will be a good husband, but you know. Okay, but men like me don't listen. Okay, that's where I got into trouble. Okay, so this is good. Okay, next we are going to look at element B now. Okay, so element B, we know that the shear stress will be its what? Maximum. Yes or no? We know element B, the shear stress will be at its what? Maximum. Okay. So at that case, this is your what? This is your Vy. Good. Okay. So now you sketch your shear flow. It's doing this. Right? So we have to take our area. Okay. So let's look at what we have. Okay. So this is also looking for Vy. Okay, this is also 25 times 10 to about 3. Now we are looking at element B. Okay, so the shear stress again is equal to Vy Qx over Txx. Okay, so again we want to find Qx. Qx is equal to A y bar. Okay, so for this case is the Q of the flange plus by the Q of the what? Web. Okay, so you just need to add them. Okay, so as I said, I like to use width multiplied by depth and then y bar. Okay, so Q flange, we're going to focus on the flange. The width of the flange is BF, so BF is equal to what? Sorry, BF is equal to 0.166. Okay, the depth is TF, the depth is what? 11.8. Okay, then the y bar will be equal to the D is 0.205, right? D is 0.205 minus by 11.8. Okay, so this is for the flange. Now the web plus the width, the TW is equal to what? The TW is equal to 7.24. The depth, so D is 0.205 divided by 2 minus by the TF. TF is what? 11.8, right? TF is, wait, 11 point. Let me check. TF is what? 11.8. Okay. Then I will take the same dimension multiply by, oh, this is a long formula. Then do this again. 0.205 divided by 2 minus 11.8 times 10 to the power minus 3 multiplied by half. Why that formula over there? Because this is the distance from here to here. Okay, so this is 0.205 divided by 2 minus by 11.8 times 10 to the power minus 3. And then this is your what? Over here, this distance is your y bar. So you half of that. Okay. So this will be equal to 0.205 divided by 2 minus 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 times by 0.166 is equal to 189.22 times 10 to the power minus 6. I'll do it again. 0.205 divided by 2 minus 11.8 power minus 3 divided by 2 times by 11.8 power minus 3 times by 0.166 is equal to 189.22. Then plus 0.205 divided by 2 minus by 11.8 power minus 3 squared times 0.5 times by 7.24 power minus 3 is equal to 29.780 times 10 to the power minus 6. Let me do it again. So 0.205 divided by 2 minus 11.8 power minus 3 squared times 0.5 times by 7.24 power minus 3, 29.77. Okay, so 189.22 power minus 6 plus by 29.78 power minus 6 is equal to 219 times 10 to the power minus 6 meter cube. Okay, I do it again. 189.22 plus by 29.78, 219. Okay, so from here, the shear is equal to 25 times 10 to the power 3, 219 times 10 to the power minus 6 divide by the Ix is equal to 40.8. Now the thickness, you have to be careful. The thickness is your what? TW. Okay, TW is equal to 7.24. So 25 power 3 times by 219 power minus 6 divided by 40.8 power minus 6 divided by 7.24 power minus 3 is equal to 18.5335 times 10 to the power 6 Pascal, and is going in this direction. I'll do it again. 25 power 3 times by 219 power minus 6 divided by 40.8 power minus 6 divided by 7.24 power minus 3. 18.535. What do you think? Finding the moment, the shear force, the axial load, and the axial load is easy. Yes or no? Finding the normal stress is easy. Which one is more complicated? This thing, yes or no? We spend so much time on this. That's why shearing stress is the worst. Okay? Once you pass shearing stress, I can throw the kitchen sink at you, you find easy. Are we clear? Okay? I hope. Okay, I throw the kitchen sink at you, you find easy. And then now the direction is important. Okay? Now we're going to do Vx. Okay? G. So now we are going to do Vx. Again for element A and for element B. Okay. Okay, so now again, we have to copy. How come it looks so small? Did I copy the right diagram? I copied the wrong diagram this way. Okay, so this is for Vx, element A, element B, right? So Vx is going in this direction, right? So Vx is equal to how much? I cannot remember at all. Vx is equal to 16 times 10 to the power 3. Thank you. Newton. Okay. So if we look at the Vx formula, the shear is equal to Vx over Iyy Qy over T. Okay. So we don't know So we know Vx is equal to 16 times 10 to the power 3. Iyy